All right, hello, this is Neve from 70258A, and this is our robot, Tom. It's our fourth iteration of our robot this season. And to start, 600 RPM on both stages of the intake, the hook, and the floating intake, also rubber banded with our polycarb like flat down here. And this runs quite well. And at the top, we actually use a 24 tooth sprocket. So we use these 3-inch flex wheels, and we actually cut them in half to not only just like reduce weight a little bit, but also it makes it a little more sturdy and more consistent. And then moving on, we have these ring pushers, which are for when we have our Mogo attached to our bot. These push the ring and ensure that the rings don't get caught on these hooks. And then now moving on to the Mogo mech, we have a class 1 lever piston Mogo mech, and it's one piston as you can see back there. These are our aligners, or they help with aligning at least, and these make sure that the Mogo is at the right angle. And it works quite well, but we do want to switch to a locking Mogo mech in the future. And moving on, our blinker over here, also pistonized, just one piston, quite a simple mechanism. And as you can see, we run not only one, but also 2 air tanks. Back there you can see one. And these license plates are custom 3D printed in the Mario font. And now also we use the a 100 RPM red gear cartridge motor for our Lady Brown. So I can showcase that here actually. We have some controller scuffs, and one part actually broke, but we just reprinted that, so we're just gonna add that on tomorrow. Tomorrow is actually our 3rd competition. And if I just press this, load position, and then press the other paddles, score position, and go back, and it works quite well. And go back here, the intake looks like this, and then I can just showcase this. Most people actually use mesh here, but instead we were prompted to use the gusset locking mechanism. It's basically a rubber banded gusset that you can push the ring through, and then basically the rubber bands will bring the gussets back to this state, so that now the ring will kind of just stay in here and it won't fall out, which is really good, especially if you're being pushed around and so. And also, this is our robotics notebook. It's quite well. It's really good actually. It's made by one of our team members, and he's also the co-leader of the club at our school. And then finally, for our code and our PID, we use this rotation sensor for the macros, and also this IMU. And I coded everything using pros, and I also used lemlib for the auton and their like coordinate system. And here's a clip of our 4-ring auton working.
Do you want to press? Oh.
Okay.
Oh!